on Chapter 8, Learning Target 4, Geometric Series. Here we go. Oh, this is Miss Osier.
And Miss Lahar.
And here we go.
She almost missed the intro.
I almost missed it. I went back. Everything's fine. Okay. Geometric Series. You were given this formula, guys.
You are given this formula on your reference sheet.
It's right there.
I don't know why it's up there. I feel like it'll pop up. Oh, there it is. But that's too funny.
Right there.
You are given this formula. And I don't know why the word or is floating above.
For fun.
Okay.
Okay.
That's your formula. Oh,
guys, you're given this formula.
Yep.
Okay. So, for a geometric series, we're going to use this guy.
Yep. You need to know less information. You just need to know your first term. You need to know what your first term is, and you need to know what your ratio is, and you need to know the number of terms. Those are the 3 things you need.
Boom. So, if we have 8 terms, the ratio's 4. I call it the rate. It's really the ratio. I just like to say rate. And then we have 3 terms. Or, excuse me, first term is 3. Plug it in. Boom. Look at us go.
Right, way to spoil the answer, too.
Way to spoil it.
Again, that's the geometric series.
You weren't spoiling. It was foreshadowing.
Foreshadowing. Oh, here we go. The answer's not popped up now.
All right, find the value of the geometric series below. Show the calculations that led you to your final answer. So I see my rate is 2. That's not hard to figure out. But again, if you didn't know, you could do 12 divided by 6, 24 divided by 12, etc. Now, don't be thrown off. It says plus. That's because we're doing a series. We're adding up all the numbers. The numbers themselves are like a sequence. So think of commas instead of the pluses.
Yep.
Okay.
So that's our formula. So we know our first term and we know our R. But the thing that we don't really have for certain is what that n value is.
Oh, so how do I find that n value?
Well, you can work backwards of your geometric series formula.
Oh.
If you know what your term you're looking for, you place that over there. You know what your 6 is. You know what your 2 is. And then you divide by 6.
Divide by 6.
And now we can go back to logs if you want.
Logs. I would totally log this.
Or common base. I might have, I logged it. But you could have done common base as well.
Yep.
2 to what power is 128?
So when you do you switch this to log base 2 of 128, you're going to get log 128 divided by log 2.
Ooh, I skipped a step there.
Common base. That's fine. And then you have the 7 equals n minus 1, so 8 equals n. So hey, now we have n, and now we can just plug all that stuff in.
And do the math, and always simplify.
So if you get stuck on a series question, it's a pretty good idea to go back to your sequence formulas and see if you can get your missing piece of the puzzle.
Oh my God, Miss Osier, it's a word
problem. Word problem. A person places 1 penny in a piggy bank on the first day of the month, 2 pennies on the second day, 4 pennies on the third, and so on. What does so on mean?
It goes on and on and on. Continuing that pattern, of course.
Whoa!
Oh no.
What just happened?
Okay,
so we can tell by the word problem that this is going to be geometric because it's 1, 2, 4. It's increasing by a ratio of 2. Okay. Will this person be a millionaire at the end of a 31-day month?
You're just going up by a penny.
You might say no, but I say yes.
Dun, dun, dun.
I just say yes because I want to. I don't even know.
Okay, so we know what the first term is and we know what it's going up by, and we want to know the 21st month.
Okay, now notice that we use the first term in cents, just because it makes more sense that way.
Oh, ba-dum-bum.
Oh, I didn't even plan it. Okay, so then we go from here. Whoa, look at all that money.
Ladies and gentlemen.
$21,436.47. Whoa.
Now the thing is, that was happening.
Right. You're not going to have enough pennies to put them away. At a certain point, you're going to run out of pennies.
Yeah.
But definitely going to be a millionaire. Sweet. Ooh. Okay. Maria places $500 at the beginning of each year into an account that earns 5% interest compounded annually.
Dun, dun, dun.
Maria would like to determine how much money is in her account after she made her $500 deposit at the end of 10 years.
Now, ladies and gentlemen, we are going to talk about something we've already talked about. Your formulas.
Your formulas. Okay, so compounding annually is the nice one that we like. We know that this is geometric because it's by a rate.
But look at those things. Well, remember how it's 1 plus r,
Yeah.
The only kind of difference with this one is we have, n minus 1. But your first value is 500, and it's going up. So remember, you're going to always have 100% of what you put in, and this is 5% more. So that's why the 1.05 is in there.
Your rate is 1.05. If you weren't sure, if you didn't believe us, you could do a couple of them. Like you could do 500 times 5% and add it and realize, like, oh, it's not 0.05, it's 1.05. Okay.
So we want the sum after 10 years. So we put in all that beautifulness.
Boom.
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 Boom, boom.
Boom. Look at us go.
Okay.
That's a lot of
A
money.
was just writing the formula.
Yes.
I at first was like, did we not answer that question? But it was just write the formula.
Look at that. It's beautiful.
The sum.
Okay. So again, notice that the geometric series and the compounding formulas we've already done are the same. Hey, there's some answers. Okay, so we have a sub 1, we have our rate, and we have the sum. So can you find out how many terms there were? So basically we're working backwards to find n. So we substituted everything into the formula to find n. Now you got to do some algebra, people. 1 minus a half is a half. Okay, so I have this over a half.
Yep.
All of this over half.
So you cross multiply, and that gets you to your step below it, which is half of 120 is 60, and then the numerator.
Yep, there are multiple ways to get to this step. As long as you get to this step algebraically correctly, you're fine. Okay, and then we subtract the 64, then we divide the negative 64. So then we're here to the 1/16 equals a half to the n, and then you can either log it or common base it at this point, and you get 4. Look at us go.
Oh, here's the other
next one. So same process. We're trying to find n. So we have the series, we have the sum, we have the first term, we have the rate because we can, figure that out. 15 divided by 3, excuse me, negative 3 is negative 5. And we're just working our way.
Yep. So, 1 plus 5 would be 6, so I multiply both sides by 6, and that's where I got to the next step. And then you subtract 0.6, and you divide by negative 0.6, and then you log it, and you get n is 9.
N is 9.
And that, I believe, is it.
Oh, we just want to show you the formula one more time. Have a wonderful day, everybody. We'll see you in class.